Okay guys, how are you? I hope all is fine. I welcome you first of all to our channel, which is Industrial Project Management, and we're going to actually discuss in this channel or produce a material which has already been actually presented in the form of research papers, journals, in the form of conference letters, or even in the proceedings. And also we're going to deal with other material which is under the paradigm of maybe research articles, research papers, or even the proceedings under these on different subjects. Right now, as we are dealing with the industrial project management, so the best way is just to combine the knowledge, combine the discussions, combines the meetings and the proceedings done in the conference and obviously by various authors, by various participants, and that is our normally this is the best way to actually enhance the capability when you're talking about at industrial level, because when there's too many heads combined together specifically to the same field, when they are dealing with different topics under the same field, obviously one can actually use that capacity and even the capability to enhance the knowledge and even the skill set for that given subject, for the given domain of work. And also that's why we have actually chosen some of the articles which are already been there in the Scholar, you can say Google Scholar Google or the Google Scholar, and we can have these access for those papers, which is obviously free of cost. So that is why we are using the data, the information, just putting it down on paper, just on the video purpose, and obviously telling you that what was the contribution of the authors and also the research workers and the participants and the scholars. And that is why we are just using this technique just to provide you the simple method of enhancing the skill and also obviously enhancing the growth of our channel as well when we are talking about in terms of the industrial skill. Okay, so that is why various PhD students, various professors, various teachers at different levels combined together, even on the basis of actually providing the guidance, advice to their students, the PhD students especially, or even the students who are working at the postdoc level as well. Normally the postdoc students are that enough professional that they can produce or edit their own research papers. But right now we are just actually enhancing our capability by providing the videos that are already been actually done with the PhD students who are actually worked with professors, and also they have actually enhanced their capabilities. And obviously the research papers are internationally approved, the journals are internationally approved, so that is why we take as an opportunity to excel our own set of skills and also provide you a medium through which you can get as maximum as possible in a quick possible time. So right now, which is the proceedings of ICT-ACEM 2017, which is the International Conference on Theoretical, Applied, Computational and Experimental Mechanics, and the Aerodynamics Parameter Estimation using the LASSO regression method from flight data. That was the Ajit Kumar and Enjoy Kant Ghosh, and Department of Aerospace Engineering, IIT Kanpur, UP 208106, India. So in this, we're going to discuss in detail what was that proceeding, so that obviously we can enhance our understanding regarding this subject given. Introduction: Aerodynamics parameter estimation is the procedure of estimating the aerodynamic parameters from the observed input and output flight. Okay. Aerodynamic parameters estimation is the procedure of estimating the aerodynamic parameters from the observed input and output flight test data. And aerodynamic parameters play a crucial role in the design of the control, navigation and guidance algorithm. Obviously, performance characterization, aerodynamic database design, fault detection and diagnosis. Accurate estimation of the parameters enhances database design, fault detection and diagnosis. Accurate estimation of the parameters enhances the quality of the task for the mentioned application. Parameter estimation using flight data has been reliably approached to achieve reliably approach to achieve the task. Various research contribution using flight data has been a reliable approach to achieve the task. Classical methods normally are because when we have the parameters, there are the estimations, there is the probability of any error. The classical methods are the equation error method, output error method, and the filter error method. These methods are used as per the complexity of the problem. Equation error method work well when there is no noise present. Okay. In measurement and process. In case of a measurement error, output error method is preferred. If both process and measurement are noisy, then filter error method is used for the parameter, okay, estimation. And that is I1 to 5. Data delta method, modified delta method, NGN method, etc. are based on the neural network app and need a tremendous amount of the data to design and train the neural network. Obviously, the other methods require the tremendous time, efforts, and data as well. In this work, machine learning based regression, which is a LASSO regression, has been used for aerodynamic parameter estimation using the flight data. LASSO actually overcomes the singularity issue of least squares estimation approach. LASSO is a regression technique introduced by Robert Tipsirani in 1996, which performs both variable selection and regularization. LASSO is an extension of ordinary least squares regression. Obviously, least square regression method is always available. The ordinary least square regression is a mathematical technique, and LASSO is the extension of that. It adds the penalty term in the expression of OLS. LASSO is capable of reducing the variability and improving the accuracy of linear regression models. Obviously, that is the purpose of improving the estimation and the parameters, normally to the accuracy with the help of this technique. And in this study, aircraft longitudinal parameter were esteemed using the following formulated framework, which is this one: argument in minutes, which will be this y into x of delta and a square plus r into this is another dimension, theta 1 and 2. You're taking the mod, and also that is theta belong to the real numbers. So this is 1. You're taking the argument, adding on. This is normally because of the least square method, you're just adding on the extension, that will become the LASSO, where obviously, okay, because this will all the formulation will work under this, all the work will done under this formulation, or will push around or work around this, where x is a set of input data containing angle of attack alpha, elevated deflection lambda e, and non-dimensionalized the pitch rate, which is this q c or by 2v. Y is the set of output data containing drag coefficient cd, lift coefficient cl, and pitch moment coefficient cm. Parameter vector theta is a set of longitudinal parameters cd naught, cd alpha, cd naught, cl alpha, clq, cl lambda e, cm naught, cm alpha, cmq, clm lambda e, and r is a constant parameter. LASSO regression uses absolute values in the penalty function. The penalty function used in this regression constrains the sum of absolute estimated values. In LASSO regression, normality is not to be assumed, unlike the ordinary least square regression. Okay. So what LASSO regression uses the absolute values in the penalty function. The penalty function used in this regression constrains the sum of absolute estimated values. In obviously, you can have this regression techniques just to get the absolute and the accurate results and values. Results and discussion. What will be derived from this? LASSO regression were used on the longitudinal data gathered on the DLR ATAS, which is normally the data or the provider search craft data. Okay, input output data were segregated to achieve x and y matrix presented in equation 1, in this, which is equation 1. Okay, so force and moment coefficients during the flight is generally difficult to measure, and they were derived and segregated using the following relations in equation 2, which is this CD, which is the coefficient of drag, minus C alpha into cos alpha, minus C and Cy or Cz, obviously Cz into sine alpha. This is Cx into cos alpha. Then coefficient of lift would be Cz into cos alpha plus Cx into sine alpha, that is 2. Then we have Cm, which is probably equal to approximately equal to y into q. Okay, so let's see what we have. Longitudinal force and moment are linearly related with the inputs acquired from the flight data for the linear flight regime. Longitudinal force and moment are linearly related with the input acquired from the flight data for the linear flight regime. The linear relation between the output and input data are shown in equation 3. The linear relation between the output and input data, okay, is shown in equation 3. CD is CD naught plus CD alpha alpha, and that is CL also CL naught plus CL alpha alpha plus CL lambda e, and this is how you're going to represent these three coefficients. Okay, so with the help of the linear relationship, and we are talking about the in x-axis and y-axis because we have to derive, and that is why what we are doing. Okay, so longitudinal force and moment are linearly related with the inputs acquired from the flight data, and for the linear flight regime, obviously these are the two fundamentals requirement for the linear flight. So the linear relation between the output and input data are shown in equation 3. This is the linear relation between the output and input data, and where CD naught, CD alpha, CL naught, CL alpha, CLQ, CL lambda E, CM naught, CM alpha, CMQ, and CM lambda E are known as longitudinal aerodynamic derivatives. We have talked in detail in our videos. We have derived the estimation and also the derivatives and the coefficients as well, so you can check those videos just on the basic level and see how you can apply and use them just to get these values which is in front of you, or the notations which is in front of you. Longitudinal aerodynamic anomalies, these are the samples when we are talking about at alpha radian. This is QC by 2v radian. This is QC by 2v radian. This is also lambda e radian. So this is how you're going to have the three sort of the three sort of the samples which have shown the three sort of results in front of you. So ATAS input and output data. This is the ATAS input and output data. Okay, so which is 70% for training and 30% for validation. And ATAS data is highly accurate and error-free, that we have already discussed. It is normally, I have already discussed, I'm just telling you, ATAS is normally highly accurate and error-free data. So that is why we can say that we can have this input and output information by having the experience of 70% of what training and 30% of validation through these topics or through these samples. So let's see what we can have for rest of the part of this proceedings. These proceedings were normally done. This is the parameter. Okay, CD naught, CL parameter, the CM. This is the LS estimate. This is LASSO estimate. These are the values. Normally, these are more found to be accurate and reliable and error-free. And when we're going to put the values on the graph, this will show first of all when you're talking about sample, but we're talking about in terms of CD. This is just a CD graph in front of you. Okay, so it has been just using this one, so you can see this the values starting from over here, LS. This is the measured one. This is the LS estimated. This is LASSO estimated. Normally, this is being graphed on the computer. I have actually not taken the snippets or what you can say the extracts of the results already been actually on the computer. I have just actually showing you this proceedings just on the text. Obviously, just taking out the notes exactly so that you can have, if you want to have, you can go through the same research that I have actually mentioned in detail from the intro, and you can get exact by exact result of this one. Okay, so conclusion: in addition, it was seen from the LASSO formulation that it's that with the plenty term, it has the capability of reducing the variability and improving the accuracy in linear regression models. So obviously, in linear regression model, we're talking the least square models, and or adding on the what, the plenty term, that will add, give up or sum up the what, the LASSO formulation. So that is why the estimated parameters results were compared with ordinary least squares estimated. So that is the least square. Just to mention that is the least square and that is the LASSO. Okay. And results are in close agreement with them. Obviously, these are two are in close agreement with each other. Okay. Additionally, this work attempts to highlight that the LASSO regression method can be a better choice when there is invariability in the data for the large numbers of the variables, and OLS suffers from the singularity and potential instability. Okay, this is how, because when we are talking about for the large number of data or for the large number of variables, and when there is invariability in the data for a very long and large number, so that is why LASSO is normally a LASSO regression technique helps and is an added advantage by having that plenty term. In that will actually reduce that actually you can say invariability point, and obviously improve altogether results, and obviously that is more error free. When you're talking about the estimation, I have already discussed, if you see, especially when you're talking about the aerodynamics, especially when you're talking about the results and the estimations in a paradigm, and the parameters obviously set on a given aircraft or given machinery, you need to understand that the results need to be accurate, crystal clear, crisp, because until and unless the results are not crystal clear, crisp, you cannot actually rely on any machinery whatsoever. You have to actually, it's not just a mean of actually, you can say, a layman term. You don't have to use the layman mindset. You don't have to use the amateur mindset. You don't have to use the ill professional mindset. You need to use some professionally sound, accurate, and obviously with the more you can say long going, and also with solid attitude towards achieving any results, when especially talking about the aerodynamics, especially talking about the flight data results. Then the results, the flight data need to be actually you can say put through, or you can say the tabulated very accurately, so that there is no mistakes whatsoever when you're talking about in any direction. If it's an x-axis, if it's y-axis, the data, it needs to be accurate and well presented, so that there is no confusion at any part or any point from starting to end. So that is why some of these techniques may help us to gain further confidence on the results, on the flight data, so that we can improve our results, we can improve our work, which is the basis of any flight, and also which is the basis of work as far as the aircraftmanship is concerned, and also from the point of pilot who is flying the machine. And normally these results needs to be very accurate, and there are tons of actually parts, and but from the perspective of a pilot, from the perspective of the pilot who is flying the machine, actually he or she normally has more accurate judgment when obviously he is or she is using the tool, if it's actually accurately made or not. For that reason, these techniques, these methods, using the mathematical techniques, mathematical estimations will help us to improve our results. And obviously these proceedings from this conference are very, very, very fruitful. And I again thank for all the contribution done from this proceedings by these two authors or these two scholars, which named as Ajit Kumar and also Ajay Kant Ghosh. And I sincerely thank you for providing your scholarly work over the Google so that we can actually present and also follow on the same lines as you were tried. And we also try to explain the same work just for the purpose of improving our viewership, first of all, just on the purpose of improving our understanding and skills, and also improving and also working simultaneously with other you can say engineering domains. We have different sort of channels for every domain. If you are interested, you can ask for the links and we can provide the links. We are working side by side on different channels which are under the domain of engineering, and ultimately working together just to have a sound understanding of an aircraftmanship. And obviously if some added information or added knowledge is also necessary, we're going to add up for any engineering point of view just to enhance our capability and just to enhance our skills when we're talking about from the entrepreneurship, and you're talking about from the perspective of actually dealing with high-tech technologies in a professional dealing within the paradigm or within the work or within the, you can say within the law of a land. And as we are talking about UP, we are talking about the IIT Kanpur, and I hope that with these videos and these publications, or this videos produced, actually it's not publications are by these well-read scholars, so we sincerely thank them. Yet again, just ending up my video on a note that we're going to produce on the same approach on, especially for this channel, which is the industrial project management, and just keeping on track how we can well adjust, well produce our knowledge already been actually worked out by different scholars, different students at different levels, even at graduate level, at postgraduate level, at graduate level, or even at the PhD level, or even at the postdoc level as well. If there are actually we find any material which is useful for us, if we find any material that is helpful in actually improving our set skill, so we're definitely going to produce them in the form of videos, in the form of media, so that we can help improve our channel, our capacity, and also to build our customer base, which is the ultimately goal of actually doing these all sort of the videos. You can check on our other links what we are doing just as a work which is the requirement of a startup, which is the requirement of any industry, setting up the goals, setting up the rules and regulations. Obviously learning is the benchmark of our channels, and that is why we're going to enhance our skills, and that is how we're going to provide you more information, obviously reciprocating the same from you guys as well. At any point, whenever down the road, in 6 months time, in 1 year time, you're going to watch the videos, you can actually share your thought process, and we're definitely going to welcome and appreciate that. So I end up my video on this note, and I hope that we're going to actually keep on sharing with the same concept, with the same approach, especially for this channel. And also do watch our other channels, and do actually which are under the domain of actually different engineering paradigms. So I'm going to end up my video again. I thank you again with lots of blessing, a lot of actually care. I hope that you're going to reciprocate with the same. Till for the next video, take care and have a nice day.